Hey everyone, welcome back again. So today we'll be discussing about generating our own test datasets for machine learning. Whenever we think of machine learning, the first thing that comes to our mind is a dataset. While there are many datasets that are available on various websites such as Kaggle and etc., what is the use of generating our own test dataset? Generating our own test dataset gives us more control over the data and allows us to understand the things in much better. So the libraries will be using to generate our test data are NumPy for numerical Python, Pandas for data framing, and Matplotlib for visually representing our data. So the basic concept we need to know before generating our own data set is normal distribution. Normal distribution, what is it? It is the most common type of distribution used in statistics. The standard normal distribution has two main parameters, that is the mean and the standard deviation. Mean is the central tendency of the distribution, whereas the standard deviation is a measure of variability. It just shows how much data is varied with the mean. I'll explain you it with the code right now here. So firstly we will be importing the necessary libraries like import numpy as np numerical Python. Then we'll be importing pandas as pd. Then we'll be importing matplotlib.pyplot pyplot as plt. Pyplot as plt for graphical visualization, and then we'll be declaring the values of mean and standard deviation. That is the mean value is, first let us assume as 0.5, and the standard deviation as standard deviation value as like 0.1. It's 0.1, not 0.1, 0.1. Okay. And then we'll be using np dot random dot seed of 0. Here we use the seed value as a base to generate a random number. If we don't mention the seed value, the system takes its current time as a seed value and generates a random data of that value. So next we'll be taking our x and y coordinates here. For suppose x is equals to, we'll be using the normal method from random module np dot random dot normal, where mean is equals to mean value. As I'm not entering as mean is equals to mean value, as they are positional arguments, and simply writing them. And then we'll be giving the standard deviation value, and then we'll be giving the size of the x coordinates as 395,1. Let's assume that is the size will be 395 into 1, and we'll be also generating few values for y as np dot random dot normal with mean value as mean value into 2. I'm just multiplying with 2, and the standard deviation value as standard deviation value into 3, let us assume, and the size will be the same, like 395 to 1. This is a tuple, 395 into 1. Perfect. Then we will be using a scatter plot using the matplotlib library plt dot scatter. This spelling mistake. Scatter of the x coordinates and the y coordinates, and let us give the color of the points as green. Yeah, G. Perfect. Then we'll be printing, plot dot show plt dot show to show the graph. Perfect. I'm now running this one. So yeah, we can see it here. Perfect. We have got few x values and y values. We got the central mean values. There is more data around the mean value. You can see, right? You can also check the standard deviation value 0.1. Perfect. Now I'll explain you in a more clear way in a machine learning approach. In a machine learning project, like for regression or classification, we'll be having few columns which will be using to predict another value. So firstly we'll import the libraries as previously what we have done. Import numpy as np, import pandas as pd, and import matplotlib dot pyplot as plt. Perfect. This time we will be also importing math to use mathematical calculations, and we will be also importing the random module. Instead of using it from the numpy, we'll be importing it separately. Perfect. Now let us assume that we have 4 columns with names point 1, point 2, and point 3 and point 4. Since we have used the math module, we can use the ABS method. ABS is nothing but it always returns a positive value. If we rate ABS of -y, it returns y. If we given positive value, it returns the same value. So ABS of np dot random dot, yeah, normal, again the same parameters. This time we'll give the mean as 1, standard deviation as 12, and the size as 100. Okay, perfect. Similarly, we'll define point 2, 3, 4, which are all columns. I'm just copying and pasting it. I'll just change the names. Point 2 here, point 3 here, point 4 here. The size will be the same, that is 100. We'll be changing the mean and standard deviation values. For point 2, let the mean be 3. For this, the mean be 3. For this 2, for this 3, and for this, let's assume 10. And the standard deviation values 12, 8, 2 for this, and 15 for this. Perfect. Next will be taking a variable x that contains the features of data set of all the points. That is, will be concatenating all these point values into a feature vector. So we can use it in a machine learning model. So let us assume x is equals to np dot, we have c underscore method to concatenate few points, right? So we'll be using the point 1, comma point 2, comma point 3, comma point 4. Perfect. So feature vector is done here, and the result variable, that is the result column, the values will be predicting of the column y. So we'll keep the values of column y between 0 and 3. Let us say it has only 3 categories: 0, 1, 2, and 3. I mean 4 categories, right? So we'll be taking a list of it. We'll be taking of int type, that is the list, and we'll be using the np dot random dot rand int, that is, we'll be getting random integers between the values of 0 and 4 minus 1, right? Okay. For in the range of, that is, I'm using list comprehension here. I'm executing the for loop in the list itself. Fine. Okay. Now we'll be creating our own data frame using the pandas data frame method. Data frame. Yeah, perfect. And we'll be introducing its columns as col1, which represents the values of point 1. Similarly, for point 2, point 3, and point 4, we'll be creating 3 other columns. Perfect. This will be the column 2 for point 2, and this will be and this will be the column 3 for point 3. This will be the column 4 for point 4. Perfect. Now I'll be showing the graphical representation of our values. We'll be using matplotlib.subplot. We'll be having 2 rows as I'm subplotting it, and 2 graphs in each row. This will be the first graph. I'll be printing it here. We'll keep the title as plt.title as col1. Sorry, it's 1 here, right? And then we'll print the scatter plot. plt.scatter of the y here, that is the result column, and the point 1, that is the first column of our input variables. Let us assume the color let be as R, and the label we'll be giving is col1. Perfect. And similarly we'll be doing for all the columns. I'm just copy pasting. Here it will be the second graph. This will be the third graph, and this will be the fourth graph. Okay. So here we'll be taking the col2 as name. It's 2. Here we'll be taking the col3, and here we'll be taking the col4 as name. Here also we'll be changing them as point 2, 3, and 4. Fine. Let's make it more visual. Let's change the colors. I will keep it as green G, this as B, and this as Y, and we'll be changing the final names of this as label C2, C3, and C4. And finally, we'll be plotting the graph using the plt.show method. Perfect. I'm running this again. Yeah, we can see the graphs, right? So for the first point 1, we have mean as 1 and standard deviation as 12. You can see it here, absolutely. Yes. And for the second, mean is 2, 3, and 10. Yeah. Perfect. 2, 3, 10. Yes. So guys, I hope you understood how to generate our own test dataset for machine learning using NumPy, Pandas, and Matplotlib, and also the random module from NumPy, or else you can import the whole random module. You can just use the np.random.normal with giving parameters as mean, variance, and standard deviation, and the size of the list, and we can include a data frame of our own to represent the data set, and we can use the plt.scatter method to print the scatter plot. That's it guys, hope you have understood the session. Thank you.